Hello, my name is Chad Varney and I'm an application engineer here at PROLIM Solutions. I'd like to welcome you to another session of NX CAM Lunch Bytes. Today we're going to look at model prep in NX CAM. We have several of you on the line with us today and you'll be in listen only mode for the session. If you have any questions after the session, you can email those to me at chad.varney@liplm.com. I want to remind you that we have all of our Lunch Bytes replays available on our website, and you can check those out at www.liplm.com. We also have a section on there where you can request future Lunch Bytes topics. So today we're going to talk about getting your model ready for CAM programming. Getting your model ready to be machined is just as important as making the actual toolpaths. After all, if you start out with a model that's incorrect, then the part out on your machine is going to be incorrect as well. I know from experience that it's no fun to spend several hours programming a job only to find a small defect in the model, and then you have to go back, fix the model after you've already programmed the job. Or it's even worse if the part actually gets ran out on the machine. So it's definitely worth taking the time to check your model and make the changes necessary before you begin programming. We've all received those models that were translated from another system and just simply modeled incorrectly, and then you have to make changes to those models before you even start. So what we're going to look at is these topics today, and hopefully you'll learn some ways to help deal with bad data. First thing we're going to look at is the file types that you're getting. Are you getting native files from NX, or are you getting files from another system? The next topic we're going to look at is analysis tools in NX to help examine your geometry. We'll look at wave linking your model so that you can make changes to the model for manufacturing purposes without making changes to the original design model. Then we'll look at using NX synchronous tools to manipulate your model to get it ready for programming. We'll also look at adding draft to your model, and then look at patching openings or gaps in the model so that your cutter doesn't try to cut areas of the model that you don't want to cut. And then we'll also look at fixing a model that was translated from another system. Alright, so let's get started. First thing we're going to talk about is how you're receiving your models. I talk to many different programmers, and I often hear about how terrible their models that they get are. Well, it's important that you request the best file type from your customer. Here's a list of file types, and these are in order from best to worst. Obviously the first choice should be NX files. Since we're working in NX, that should be the file type that you should request. The NX file type is a .prt file, and with this you should be able to get the model history so that you know how the model was created or designed. The next option would be a solid edge file. This should be a .par file. Solid edge and NX are both Siemens products, so this is a direct file open into NX. Also, there's some interoperability between NX and solid edge. The next option would be a parasolid. Siemens owns the parasolid kernel, and there's a lot of other popular CAD systems that use this kernel. So if your customer is using a different CAD package, you may want to see if they can export out to a parasolid file. This is going to be much cleaner data than the next two options. The next option is a step file. This is a .stp or a .step. Step files are pretty common and can be imported and exported with most systems. You may have some issues if it is translated from another system, but that may be all that you can get. And then the last is an IGES file. This is a .igs or a .iges. IGES files are pretty universal but can produce some very poor data. We're going to look at an example of a bad IGES file later, and then how we can deal with that. Alright, so now let's take a look at NX and talk about some of those analysis tools. we have our standard analysis tools over here on the left. But I want to show you two analysis tools that may be useful on a part like this, or maybe a plastic injection molded part. The first one is check wall thickness, and what this will do is it will show you the wall thickness of the part. So I just simply selected calculate thickness, and then notice over here in the graph it will show you the thickness of the part. So the blue is basically 0 thickness, and then all the way up to red is about 3 millimeters thick. So you could check for your wall thickness around here. Alright, so this wall thickness looks pretty consistent, but if you actually flip this over and then notice there's a boss shape on the top of this, notice it's near 3 millimeters as far as wall thickness. Alright, so this is a good tool to kind of help you know what the wall thickness of your part is. And then the second one I want to show you is analysis on our draft. So we're going to use draft analysis. Alright, and then we're going to pick a vector for our direction. Alright, and then we're going to simply select the part. Alright, and then notice we're going from 0 to 5 degrees. So it's displaying anything that's from 0 to 5 degrees. Notice close to 0 is blue, and then it turns to yellow, and then green is more than 5 degrees. So let's adjust this up a little bit, okay, to about 7.5, and notice we're going from 0, and then yellow is up to about 7.5. So from 0 to 7.5 is displayed in yellow. So these surfaces here are basically 0 degrees, and then we have these surfaces in yellow, which are probably right around about 5 degrees is what it's showing us there, all the way up to anything greater than 7.5 degrees. So, and then the red would be like the undercut shapes, which are like on the bottom of the part. So if this is a plastic injection molded part, then that would probably be on the other half of the mold. So this is a pretty handy tool as well. Alright, and then in our agenda we talked about wave linking geometry. So that's what we're going to talk about now. What we're going to do is wave link our geometry, and that'll allow us to make changes to the model for manufacturing purposes. Alright, these changes are going to be made to a linked body instead of the actual design model. For example, maybe we want to delete features that we don't want to machine, or maybe offset surfaces, things like that. We want to do that for machining purposes, but we don't want to actually change the design model. What we're going to do is create a linked body. Alright, so we're going to use the master model concept, create a manufacturing template, and then once we've created basically a manufacturing assembly, we're going to create a linked body. Sometimes I get the question, well, why do you go through all that trouble to create a linked body? Why not just make a copy of the model? Well, the reason is the copy of the model is not associative. That means if something changes in the original design model, your copied model doesn't update. Well, with a linked body, the linked body will update if the original design model changes. So let's take a look at an example. So for example, if we were going to start machining this, a best practice would be to use the master model concept and do a file new, select a manufacturing setup, and then the first thing I would do is go ahead and create a linked body. So this is the original design model right now. We don't want to make any changes to that for now. We just want to make changes to a linked body. So for manufacturing purposes, we're going to make an associative linked body. So basically we're just going to select the body and notice we had hide original selected. So notice the original design model is hidden, and now all this being displayed, and as you can see as I hover over this, is just the linked body. Alright, so now I could go ahead and make changes to that. For example, if I wanted to change the diameter of these holes, maybe offset this flange, something like that, we could make changes to this and it will not affect the original design model. So I mentioned earlier that this is associative back to the design model. So if something does change in the design model, it will be reflected in this linked body. So let's take a look at an example of that. I'm going to go back into my assembly, and I'm going to actually go back into that original design model. Notice up here, this is the original part. Now I'm going to make a change to that. I'm going to do an offset region and maybe make this flange on the outside a little bit bigger. Notice I had tangent faces selected for my selection intent. So this selected all the tangent faces around the outside of this flange. And I'm just going to go ahead and pull this out about 10 millimeters. Okay, so I've now made this outside flange bigger in the design model. Now let's take a look and see what happens to our linked body. So now I'm going to go back into the manufacturing setup, hover over this, notice that this is the linked body being displayed. And notice this flange is changed. So this again is different than just creating a copy of your design model. This is associative. So if we had made machining operations on this flange, we would just now be able to just regenerate those since the linked body has been updated. Alright, and let's go ahead and do an example of making a change for manufacturing purposes. So let's say for manufacturing purposes, we don't want to cut these indentions right now. We just want to cut this outside shape nice and smooth. What we can do is remove those indentions on the linked body, and that will not affect the design model. I'm going to use synchronous tools to delete these features or indentions on the part. I'm just going to do a few of these just so that you get the idea of how this will work. So now I've deleted those indentions, and again that is just on the design model, or I'm sorry, on the linked body. The design model hasn't changed. So let's go ahead and turn on that design model, and actually let me go ahead and change the color of this first. And I'm just going to change this maybe to a darker blue. Alright, and then we'll go ahead and display that original design model. So notice the darker blue is the linked body, and then that original model is the lighter gray color. So notice these are covered up. So again, that's a good example of being able to use synchronous technology to manipulate your linked body for manufacturing purposes. You know, another option that you could do is maybe you don't want to machine inside this hole. I could use delete face there as well, and then that will cover that hole up. And again, this is just in that linked body. Okay, now let's look at some more synchronous modeling changes that you may want to make to get your model ready for manufacturing. So let's assume that we're going to start manufacturing this model. Again, I'll go ahead and do a File New and get into the manufacturing environment. And then I will also create a linked body. Make sure it's associative. I'm going to hide the original. So now I want to make changes to this model, again for manufacturing purposes. So let's say that we maybe have a print from our customer, and we also got the model, but the print and the model don't match. Well, if we need to make changes to the model to match the print for machining, we can easily do that with synchronous tools. So let's say for an example on the first change we notice that the print doesn't match on this outer boss shape. We need to offset that outer boss shape. We can use the offset region, and offset that outer boss shape. Let's say that our print says that that needs to be maybe 30 thousandths bigger. So now I've went ahead and made that change, and then I can go ahead and do the same thing on the top side. I could do a move face there and offset that basically by 30 thousandths as well. Let's take a look at these hole diameters. I can resize these hole diameters if I need to. I'm going to use resize face, pick one of the holes, and notice that we have the option, alright, for the system to automatically pick equal radius. And notice it picks the equal radius on this bolt circle here, and then I can actually pick all of the equal radius in the whole model. It tells me that these are 157 diameter, and let's say that our print says that these need to be 1875. Alright, so now I've just changed the diameter of all of those holes. Alright, and then another change would be maybe on this inside feature. Let's say you're going to maybe machine this hole or cut out here on a different setup. You may want to go ahead and delete that out of your model for machining purposes for now. So I can go ahead and just use a delete face and delete that out of the model. One more thing that you may want to do is, let's say that the print says that these boss shapes, the top of these boss shapes may need to be maybe a negative tolerance. Let's say you have a +0, -5 thousandths tolerance. So you want to machine these maybe to the lower limit. Okay, what you can do there is use a move face, and again you only have to select one of these, and if you turn on coplanar, it will actually select all of these boss faces for you, any of the faces that are coplanar. So then in this case I may want to drop that down to maybe -5 thousandths to machine that to the lower limit. And then one other thing that you'll notice that this flange is incomplete over on this right side. Notice it doesn't look like the left side here. So there's an incomplete shape there. Well, if you aren't able to get a correct model, back from your customer, you could make this change on your own using synchronous. So for that, I would use a pull face, and you could take this face and start to pull it in order to create a flange just like it is on the other side. Now you say, well, I'm not exactly sure how far to pull that. I could go in here and measure that, but one thing I want to show you is if you right click on the arrow and you snap to object, you can actually select the face on the other side, and it will make this pull face even with the face on the other side. And then I'll just do one more pull face in order to complete this flange. So I'm going to pull that face, I'm going to start to pull it in, and I could use that snap to object here as well. Snap to object, and then I'll just pick this face. So now with just a few steps we're able to create that flange to match the other side. So again, using synchronous tools for model prep really comes in very useful. So now let's take a look at a model that has some rib shapes, and we'll look at some different things that you can do with rib shapes. Alright, as we look at this model, notice these rib shapes down through the middle here. As far as machining goes, these may not be shapes that you actually machine. These may be possibly EDM shapes. Well, you may not want to actually let your cutter go inside of each of these ribs, so you may want to make like maybe a cover surface or something like that over top of these. Well, one way you could do that is with synchronous modeling. Alright, so we really just want a cover over top of these, and leave these rib shapes here, and then maybe come in with an electrode for EDM later on. So I'm going to use synchronous, and I'm going to use the replace face option. So I'm going to take this face and replace it with this face, and notice what happens here is it basically builds a cover surface for us. Now obviously I didn't create a linked body. This is definitely something that you would want to do on your linked body. Just for time purposes, I didn't create a linked body out of this model. That's definitely something you would want to do. Just as an example, you could use replace face and build your manufacturing model how you want to cut it. Okay? And then if I wanted to maybe extend this smaller one over to that, I could do a replace face from here to here. And then it extends that over, and then so on. And then one other thing that I want to take a look at is if we look at this part from the top view, notice that there is no draft on these ribs. Well, let's say again, maybe you get a print that specifies that all ribs have to have maybe a certain amount of draft, or maybe you have a certain requirement as far as the thickness of the rib. Maybe you can't change the thickness up at the top where it meets the part due to maybe sink issues on the other side of the part, and you have to change this draft angle. Well, what you can do is use the draft option. We'll go ahead and put some draft on these ribs. So I'm going to use draft. Alright, we need to specify a direction, so it's going to be in this direction. Alright, and then we're going to select a stationary face. So this is basically where the draft is going to start from. And then we're going to select the faces that we want to draft. So I pick the actual face of the rib, and notice it starts to draft from here, so this dimension isn't going to change, but the dimension down here will change, obviously. So now I've got a -2 degrees on each of those faces. So I can pick multiple faces, especially faces that intersect with our stationary face. So I'm going to go ahead and do these smaller ribs. Alright, so we're adding 2 degrees of draft on each of these smaller ribs. Okay, so once you get that done, now we can actually check the dimension or the thickness of the bottom of the rib shape. Notice this is 0.43. Well, for example, maybe let's say our requirement is it has to be at least 0.5 thickness on those ribs. Well, it's a simple change to make. If I just double click back into the draft command, I can actually just change that draft dimension or the draft angle. So instead of -2, I'm going to go -1.5 and then hit OK, and then we'll check our dimension. Okay, and then that's right at about 0.5 millimeter thickness, so that looks good. So again, the draft command is a nice way to create draft on your rib shapes or any kind of draft that you may need. Alright, so let's take a look at an example of where you might have a hole or cutout in an area where you may not want your cutter to be able to cut. So in this part I already have an operation generated, and notice it's coming inside this hole. Okay, it's wrapping around these edges of the surface, and it's wrapping all the way around this part. One thing I could do would be to go into the operation and then just select this face for the cut area. And when I do that, that definitely helps the fact that the toolpath doesn't wrap around here anymore. But notice I get a lot of these connection moves where it's not smoothly going across this surface. What I really want to do is have my toolpath come all the way across this surface. Well, one way to do that is to put a patch over top of this surface. So I can do that by doing patch openings, and I'll simply select the face that I want to patch, and then select the edge where you want the patch to be located. Now I just patched a hole. You can patch any type of geometry. Let's say that your data is maybe incomplete, you've got some missing little surfaces or something like that, or maybe a slot shape that you don't want to cut yet. You can use patch openings. Now if I generate this again, I'm actually going to get the same result. Okay, so what I actually have to do is I need to add this patch openings into our part geometry. So if I go into the workpiece, specify part, notice I need to select the actual patch opening, and then if I regenerate this and then select the patch as my part geometry, notice I get that nice smooth cutter path going all the way across the part. So patch openings is a nice way to fill in gaps or holes or things that you don't want your cutter going into. Alright, let's take a look at the last example. This is going to be an example of an IGES file that actually is really not a very good translated IGES file. So as you can see here, notice that this is an IGES file and it does not even come in as a solid. This comes in as all separate bodies. Okay, and you can see here that the translation is not very good. We've got these surfaces that are extended out past the edge of the other surface. It's just not very good data. So let's take a look at a couple ways that we can fix this model. First thing I can do is go to our surface command, and I can use trim and extend. And what I'm going to do is use the until selected. I really want to trim this edge to this surface. And actually you'll notice that down here at the bottom, these edges on the bottom of this surface is not trimmed either. So I'll need to fix those as well. So go ahead and apply that. Select this top edge, and we want to make it even with this other connecting surface. Now I'm going to need to go ahead and change my model to maybe a static wireframe so that I can pick the edge at the bottom, and then that needs to be trimmed to the bottom of this pocket. Same thing on the other side. Okay, so that looks better, but now we still have all these individual surfaces. These are not solids yet. Okay, and what I really want to do is eventually I want to delete this feature out of the top of this, and then maybe put a cover surface over top of this for machining purposes. So in order to do that, we should probably go ahead and make this a solid. So the first thing I'm going to do is use the sew command. So basically I want to sew these bodies together, these sheet bodies together. So I'm going to pick the first sheet and then sew all of these sheets together. And if I hit apply, notice we have an error here. Alright, and then it kind of shows you some of the areas that are not quite up to par. Alright, and then if I go ahead and click on the sew operation in the history tree, notice that it shows us in yellow or orange that these are all connected except for this top shape. Alright, one way to fix that would be to loosen up the tolerance just a little bit. So let's go ahead and do that. Let's delete this and try a new sew command. So let's sew this together. Again, I'm going to pick one surface and then all of the rest of the surfaces so that it sews it all together. And then notice this tolerance is pretty tight. It's set to 0.1 millimeters. So let's change this to maybe 0.05. Notice I do not get the error. And if I change my selection filter to solid body, and if I hover over this, this is a solid body now. And also if I select the sew operation in the part navigator, notice it does show us that this is sewed together. If we take a closer look at this, notice I changed that tolerance to 0.5. Notice we have some gaps in here. It doesn't look quite good enough. Well, one thing that we can do is use an optimized face. This is part of synchronous. So if I go to my synchronous tools and use an optimized face, this will actually heal up this model. So notice it gives us a report of what has changed after we ran the optimized face on this. Notice we had 25 B surfaces before, now it's only 6. We had 0 blends, actual blend features before, now I actually have 13. So let's go ahead and take a look at this. If I zoom in on this shape here where the radius connects, notice that it is a lot better. So now we should be able to do our synchronous changes. If you're not able to do synchronous changes, or your model isn't looking correct, or you have some gaps, go ahead and try to use that optimized face and then try your synchronous changes. So again, like I had mentioned before, maybe we want to only do the outer portion of this outside shape, and not this detail in here. So I could go ahead and delete that detail out. Obviously I would want to make a link to body first, but for this demonstration we're not going to take the time to do that. Alright, so now I can go ahead and delete that feature out. So now I would have a nice smooth toolpath going across this shape. Alright, and then next, maybe I want to machine the bottom side of this part, maybe around the outside here, but I don't want my toolpath going inside this pocket. I want a nice sharp edge here, so I really want to machine that pocket in 2 different operations. I want to do the outside and then maybe the pocket separately. So really I need a cover surface over top of this. One thing we could try to do is maybe to delete faces out of here, and then see if we can get this to basically heal up these faces, or delete that pocket out of there. Well, because of the complexity of this shape and where these shapes are B surfaces, and they're basically coming together at a point, that's actually not going to work in this situation. So in this situation it may be better just to build a cover surface. And in order to do that, I would use the command called insided surface. Okay, I'm just going to start picking edges, and then it will actually start to build surfaces. Well, notice what happens when it builds surfaces. I don't have an actual line across here yet, and if you take a closer look here, this actually isn't really smooth or tangent to the original surface. So that's not exactly what I want. So what I'm going to do is just simply add in a curve, and that'll give us a little bit more control over what this surface is going to do. So now I'm going to go back to the insided surface and select the edges, and then there for my 4th edge, instead of it kind of picking that edge for me, I'll actually just pick that line that I just created as an edge. So that'd be a pretty good way to go ahead and cover up that surface. Alright, and then now around this outside shape I can do the same thing. I'll use insided surface again and pick the edge, and notice it chains all the way around this edge because my selection intent is set to tangent curves. And then I'll also go ahead and pick that curve that I had created. So now we have a nice matching cover surface over top of this pocket. So now when I do my machining, I can use this as my part selection and cut this top side, and then maybe go back in and delete these or suppress these surfaces and then cut the pocket later. That'll leave a nice smooth edge instead of trying to cut all of this at once. Well, that's all the time we have for today's session of NX Lunch Bytes. I hope today's session was informative, and I hope that it will help you the next time you have to edit or repair your data. If you have any questions about today's Lunch Bytes sessions, please email those to me at chad.varney@allyplm.com. I also want to encourage you to go to our website at www.allyplm.com and check out our current NX training options. We offer a 1-week Essentials for NX Designers class and also a 1-week NX CAM Fundamentals class. These classes are taught here at our Cincinnati, Ohio location or online. I want to thank you again for joining us. Have a great day.